equations. This time solving systems using substitution. Gavin, turn around and face the front, please, and thank you. So we're going to use substitution. So I want to talk to you about what the substitution method is. So the goal here, the first thing that you want to do is you want to get one variable alone on one side of the equal sign for one of the equations. I'm going to say that again. You want to get one variable alone on one side of the equal sign for one of the equations. Do you guys know what that's called? You can sit right there. What's the matter? What's the problem? Okay. It's called isolating a variable, right? When you get a variable all alone, it's called isolating. So you have to isolate one of the variables. It doesn't matter if you isolate the x or the y. And today we'll talk about which time, like sometimes it's easier to isolate x. Sometimes it's easier to isolate y. Okay, we'll talk about that. So once you get one of the variables all by itself, you are going to substitute. That's why it's called substitution. Substitute. I can never spell this word. Substitute the expression, right? Because you're going to have like y equals something or x equals something. So you'll have an expression into the second equation and solve. Okay, so let's say that we got y all by itself, like this first equation right here. Y is already all by itself. So what I would do is on the second equation, I would take this expression right here and substitute it in for the value of y. So that's what I'm going to do. And then I would solve. Lastly, you use the solution from step 2 to find the other variable. So remember that the solution to a system is an ordered pair. You need to have an x equals and a y equals. You need to have an x equals and a y equals. So we're going to start with number 1. And it actually had all the steps written in there, and I kind of whited that out before I made your guys' copies because I want us to think about it. So step number 1, isolate. That means get it by itself, one of the variables. Are one of the variables already isolated? Yes, which one? Yeah. Y is already by itself, and y is the value 3x plus 2. So the second thing you're going to do is substitute 3x plus 2. That's an expression in for y in the second equation. And I want to show you what that looks like. So for this equation right here, I have x plus 2. Instead of writing y, what expression am I plugging in there for y? 3x plus 2. We said y equals 3x plus 2. And then I have to finish this equation equals 11. So this right here is the second equation, but instead of using the variable y, I use the expression 3x plus 2. How do I get rid of the parentheses? I have to distribute. So x plus, let's see, 2 times 3x is 6x, plus 2 times 2 is 4 equals 11. So now I have to do some combining like terms. add the x's. So 1x plus 6x is 7x plus 4 equals 11. Trying to solve for x. What do you want to do now? Yep, subtract 4 from both sides. 7x equals 7, which means what? Yeah, x equals 1. So now the third step. You use x equals 1 in the first equation. So I'm going to go back to the first equation, y equals 3x plus 2. But instead of x, what am I putting in there? 1. Y equals 3 times 1 plus 2. But what is 3 times 1? So y equals 3 plus 2, which means y equals, okay. So I have an x equals 1 and a y equals 5. What do I do with that? Write it as an ordered pair. 1, 5. So we're going to do it again. Only this time I'm not going to write down the steps. We're just going to do it, okay? I'm going to wait for you, hon. You with me, girl? Okay. All right. So for the one that says your turn, number 2, we're going to talk about it, but I'm not going to write down the steps, okay? So what do we do first? Isolate a variable. Do I have a variable isolated? Yes. This represents y. Does everybody see that? So it says y equals this. So in the second equation where I have the y, what am I going to put there? 2x plus 5. So 3x plus, instead of using y, I'm going to put 2x plus 5 equals 10. So I just replaced the y in the second equation with 2x plus 5. Now what do you want to do? Brody, what are you thinking? Yeah. Perfect. Next step, anyone? Yeah, subtract the 5 from both sides. So 5x equals 5. Next step. Yeah, divide both sides by 5, and I find out that x equals 1. What do I do with that x equals 1? Plug it back into the first equation. Yeah. Y equals 2 times 1, because x is 1, plus 5. Y equals, let's see, 2 times 1 is 2, plus 5. That says y equals 7. What do I do next? Plug it in and make sure that I write it as an ordered pair. So we're going to check this really fast because I want to show you how to do the checks. And I want to show you how to do the checks with a calculator. So I'm actually just going to pull up a Desmos calculator, I think. Because you need to do checks, right? You should always check your answer to make sure it makes sense. So I'm just going to go to Desmos Scientific Calculator, and I want to show you how to put it in. So someone tell me what our solution was. It was 1, 5, right? Wasn't it 1, 5? Oh, 1, 7. Thank you. Okay. So for our first equation, we have y equals 2x plus 5. What is the value of y? 7, right? So all I'm going to do is check the other half of that. I'm going to put in 2 times 1 plus, 2 times 1 plus 5, and it better equal 7. You see how that equals 7? So I've checked the first one. Now I'm going to go to the second one. The second equation is 3x. How do I clear that? So 3 times 1 plus 7, and it says that that equals 10. Our equation says it equals 10. Did we get that it equals 10? Bam, I've checked them both. Does that make sense? Do your checks on a calculator. You don't have to write it down all the time. Do it on a calculator. Just verify that they work, okay? All right, let's go back to the second example, guided number 3. So on number 3, we don't have an equation that says x equals or y equals, but I do have an equation that does not have a coefficient on one of the variables. I have an equation that does not have a number attached to one of the variables. What equation is that? Yeah, the first one. Who said that? Corbett, was that you? Awesome. So I'm going to take this equation right here. And because there is no coefficient on the x is going to be the easiest variable to isolate. How do I get x all by itself? I have to get rid of that negative 2y. How do I cancel out a 2y? Add it, yeah. Plus 2y, plus 2y. So x equals 2y minus 6. So I'm going to take this expression right here that says x is this, and I'm going to go and plug it in right there where the x is in the second equation. So the second equation is 4x plus 6y equals 4. But instead of writing 4 times x, what am I writing? 4 times what? 2y minus 6 plus 6y equals 4. Now I have to do some distributing. So 4 times 2y is, and 4 times negative 6 is negative 24 plus 6y equals 4. Let's combine some like terms. Gavin Kane, what 2 terms do you see that I can group together? 8 plus 6 is? So I have 14y minus 24 equals 4. What do I need to do now? Yeah, good job. I'm going to add that 24 on both sides. You guys are doing awesome at this. So 14y equals 28. Divide both sides by 14, and I find out that y equals what? So this is the first time we've solved an equation where we got y, the y solution first, right? So what do I do with that? Plug it back into the first equation. X minus 2y equals negative 6. But instead of the y, I'm doing x minus 2 times 2 equals negative 6. Let's see. Negative 2 times 2 is negative 4 equals negative 6. What do I want to do with that x minus 4? How do I get rid of that x minus 4? Yeah, add that 4 on both sides. So x equals negative 2. So my solution is negative 2, positive 2. So I'm going to check that. I'm going to check that in Desmos. So I'm going to go to Desmos, calculator really fast. And my first equation is x minus 2y. So that means negative 2 minus 2 times y was 2. And I got that that equals negative 6. What does my equation say that the first one equals? All right, right on the money. Let's check the second one. The second equation is 4 times x. So I have 4 times x is negative 2 plus 6 times y, which is positive 2. Whoops, that's not plus. That says equal. Sorry. I have a big old plus there. And I have that that equals 4. What does my equation say that it should equal? Boo, done. Okay. Is that all right? Okay. All right. How about if ma'am. So I want all the guys to do number. Guys, do you want 5 or do you want 4? 4. Okay, guys do 4, gals do 5. Guys do 4, gals do 5. I'm going to freeze the screen. Are we ready to look at them? Nope. Okay, that's good. That's good. So you solve for y, but this is a negative y. You see that? You see that this is a negative? So you need to bring down that negative. So how do you get rid of the negative? Yeah, by the so really, house to y equals x minus 3. So let's turn that into x minus 3. So 2 times x is 2x. Okay. So x equals 2x, which is 3x. 3x minus 6 equals negative 6. Okay. I need to go upstairs finally. Take that and plug it in. We're solving for x. That's right. Y plus 3. Okay, so take that and plug it in for here. So rewrite this equation. But instead of writing x plus 2y, we're writing what I don't want you to use x. This is what you're solving in the second equation. So what I want you to write y plus 3 plus 2y. 2y equals negative. Now solve it. So you have a y and a 2y.
I think I understand what it is.
All right, guys, I'm going to present the gentleman's side. So I thought it would be easiest to get x all by itself. So and you might have done it differently, but what I did was I added y to both sides. So I got that x equals y plus 3. So that's what I wrote right here. So in this second equation, I replaced the x with what? And that's what this is right here. Y plus 3 plus 2y equals negative 6. 1y and 2y is 3y plus 3 is negative 6. When I subtracted 3 from both sides, I found out that y equals negative 3. Then I took the fact that y equals negative 3 and I plugged it back into the original equation. X minus negative 3 equals 3. Well, what's minus a negative become? Plus. So x plus 3 equals 3, which means x is 0. So the solution is 0, negative 3. Now, if you had solved for x, or if you had solved for y, you would have gotten that y equals. Do you want me to show you what solving for y looks like? So I would have had to subtract x from both sides. And some of you guys dropped your negative. There's a negative in front of the y. So that means negative y equals negative x plus 3. Then I would have to divide everything by a negative. So y equals x minus 3. Okay. Once you do that, you still get x equals 0, right, Dakota? So if you solve this way, you still get x equals 0, and then you have to plug in and find y. Okay. So your solution again is 0, negative 3. Ladies. So for you ladies, here's what I did. You see how y is already kind of like almost by itself? It doesn't have a coefficient. Thank you, Antoine. So I close the door. I subtracted 3x from both sides. So this is what I started with. Y equals negative 3x minus 7. So I went to the second equation right here, and I replaced my y with a 3x minus 7. So I had to distribute. So negative 2x minus 12x minus 28 equals 0. I added 28 to both sides. Negative 14x equals 28, which means x equals negative 2. Then I had to go back to the first equation and take what I just solved x for, which is -2, and plug it in. 3 times -2 plus y equals -7. Well, 3 times -2 is -6, plus y is -7. I added 6 to both sides, and I got y equals -1. I'm going to leave that up there for one more minute, and then I'm going to move on. We have a word problem. A word problem. We're going to skip that word problem, actually. I don't even want you guys to freak out. We're going to skip that. We'll do applications on a different day. Okay. So your homework